All right, guys, good morning. Today we're going to be talking about 6.5, three theorems involving proportions. So we're still going to be working with similarity today, but again, we're going to be focusing on three important theorems that we can use throughout similarity problems. And all of these will be dealing with proportions. So again, we're going to be setting up two ratios that are equal to each other. So first off, recall, a midsegment is a segment connecting two sides of a triangle, is parallel to the third side, and half as long. So if I see that we have a midsegment, and again, a midsegment is intersecting at the midpoints, I can tell that it's intersecting at the midpoints because one side is congruent to the other. So again, this is in the middle, as is this other point. Well, if that's the case, these lines are parallel to each other, the 20 and this midsegment here. And also the midsegment is half as long to the side it's parallel to. So if that is A, we can go ahead and solve for it. A will be half of the side it's parallel to, which is 20. So A is equal to 10. So that is just a little bit of review. We should remember that from previous lessons. So again, we're going to be dealing with parallel all throughout the day, and that's why I really wanted to mention this, because parallel is key for us. Whenever we see parallel lines, we can use any of the theorems that we talked about today. Now, one of the most common ones that we're going to be talking about is this first theorem called the side splitter theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. So what this allows us to do is split up the sides of our triangle. So if I have a triangle here, two triangles rather, and I see that we have parallel sides, let's go ahead and call this A, B, C, and D, just as random variables. They can be any numbers really. Well, what the side splitter theorem allows us to do is split right through the middle. So I'm splitting down those parallel sides, and I'm splitting right down the middle here. It's very important that I'm going through the lines that are parallel. I'm not going from over here or anything. I'm going through both parallel sides. So that's why they call it the side splitter, because now when I create my ratios, I'm going to stay on the same side. So therefore my ratios are A over B equals C over D. Whoops. So again, just real quick, it'd be A over B is equal to C over D. And again, that's for any triangle. And again, it's very important that it has parallel sides there. If it doesn't have those parallel sides, then we can't actually do that. We can't actually use our side splitter theorem, A over B equals C over D. So very important that those sides are parallel to use this. And again, they're just grouped together and grouped together. All right, so let's go ahead and try out a practice problem with these, with the side splitter theorem. Here's our first one. It says solve for x. So we have this unknown variable x. And we won't actually use the side splitter theorem here for this because we don't need to. Of course, we do see that they're parallel, which is very useful for us, but we don't necessarily need to use the side splitter theorem. So the first thing I'm going to do is I'm going to take both of these triangles, the small one on top and the large one overall, and I'm just going to draw them out next to each other. So here's one triangle and there's the other. Now you may notice that this side length is 7 over here. The way that I got the 7 is I just added 5 plus 2 to get the full side length. Now from here, we can set up our proportions because we have corresponding sides. 5 goes with 7, 15 goes with x. So I'm going to use my big triangle over my small triangle for my ratio. So I'm going to have 7 over 5 equals x over 15. And again, we're just mapping the corresponding parts together. From here, we can go ahead and cross multiply to solve. This will give us 7 times 15 and 5 times x. So we have 5x equals 105. Of course, if I divide both sides by 5 to get x by itself, we'll be left with x is equal to 21. And that's our final answer. All right, let's go ahead and continue. This time we're actually going to try out the side splitter theorem here. So looking at this, a big key for the side splitter theorem is that if you have numbers on both sides of your triangle and you see those parallel lines. Very important that those are parallel. So we can go ahead and do this problem by creating our proportion and splitting our sides. Now I'm trying to dodge the 7 and the z down here so I can make sure that I can use those later. So we're going to go ahead and solve for x, y, or sorry, just y and z. We don't have an x. So I'm going to start by solving for y. So since I'm using the side splitter theorem, and again, I'm just splitting those sides because we have parallel lines, my ratio is going to be 2 over 6 equals 3 over y. As you can see, I'm staying on the same side when I'm creating my ratios. Now, could I do 6 over 2 equals y over 3? Absolutely. At this point, we're just going to go ahead and solve for y by cross multiplying and solving. So we'll give us 2y equals 18. And of course, if we divide both sides by 2, we're left with y equals positive 9. Now from here, now that we know that y is 9, we can now solve for z. And of course, I could have solved for z first as well. So to solve for z, I'm going to use my small triangle on top and my large triangle overall. So as I can see, we have 2 and 6 here, so the full length would be 8. So I can go ahead and set up my ratio of the small triangle 2 over the large triangle 8 is equal to the small triangle 7 over the large triangle z. And again, I'm just mapping up corresponding parts. If you need to take the triangles apart and draw them next to each other, that's fine as well. From here, we can cross multiply and solve. This will give us 2z equals 56. And dividing both sides by 2, we get z equals 28. That's our final answer. All right, let's go ahead and continue and try out our next theorem. So that's it for the side splitter theorem. Again, if they're on the same side and you have parallel lines, you can split it down the middle to create your proportion. All right, our next theorem, again, involves parallel lines. So again, that's our key for this lesson. If 3 or more parallel lines are intersected by 2 transversals, the parallel lines divide the transversals proportionally. Now, this is the same concept as what we just worked on. It's the same concept as the side splitter theorem. So looking at this, we have more than 3 lines that are parallel. So again, what we can do is we can split it down the middle and set up our proportions on either side. I'll use a different color here. So therefore, I would have 2 over 4 see if it popped. Nope, it didn't pop up. So we'd have 2 over 4 equals 3 over b. So again, I'm just staying on the same side when I'm creating these ratios. Obviously, I don't want to have b and c in the same proportion because then I can't solve for it. But looking at this, we should be good to go in solving. So from here, we can cross multiply, giving us 2b equals 12. And then from here, we can divide both sides by 2 to get b by itself, giving us b equals positive 6. Next, we're going to go ahead and solve for c. So I'm going to use my top numbers up here. Again, I can use 4 and 6 now, but if I messed up in solving for b and I used it to solve for c, then my answer for c would be wrong as well. So I would get 2 over 3 equals 3 over c for my next ratio. And again, I'm staying on the same side. From here, we cross multiply, giving us 2c equals 9. And dividing both sides by 2 will give us c equals 4.5. So again, if you have a lot of parallel lines, just use that side splitter theorem, split them down the middle, create your ratios on the same side of your figure. All right, our final theorem for the day is the angle bisector theorem. It states a ray that bisects an angle of a triangle makes the opposite sides proportional to adjacent sides. So the main thing that we need to do here is we need to label our triangles when we're doing this. So let's go ahead and see what one of these looks like. Here's our first one, solve for y. Now the main thing here is when we look at this, the way that we know that we can use the angle bisector theorem is if we have 2 angles that are congruent right next to each other. Obviously, these angles are congruent. They're being split by a segment, meaning that this is an angle bisector that's occurring. cutting the angle in half. That's why they're congruent. So we're going to start by labeling the sides. Now the side opposite this angle, I'll call opposite. So if I'm going from the angle, I just go through my triangle to get to the opposite side. Meanwhile, the other side that we're given is the adjacent. Now I'm not going to ever use the angle bisector for this. I'm always going to use the sides of the triangle. So I start labeling. Adjacent again just means next to, so it's next to the angle. And then opposite means we have to go through the figure. So I'm going to go ahead and label this as adjacent and opposite for each of our angles. So I have the red angle here, and opposite and adjacent. Then for my green angle, y is opposite and 15 is adjacent. So now we can set up our ratio. I'm going to use adjacent over opposite. This will give me 10 over 4 equals 15 over y. Cross multiplying will give us 10y equals 60. And then dividing both sides by 10 to get y by itself will give us y equals positive 6. So again, always label those sides. It's very important that you guys label it as opposite and adjacent. Again, adjacent is just next to the angle. It's the side next to it. And then opposite, we have to go through the triangle. I'm not going along any side. I'm going through the middle of the triangle to get to the opposite side. Very important that you label these because we'll continue doing it into the next unit as well. All right, let's try out one more. Here's our final one, solve for z. Again, we look at this, think about what we can use. Do we have parallel lines? No. Side splitter theorem's out. But we do have congruent angles, and they're being split by a segment, meaning that they are angles, congruent angles, and this is an angle bisector. So we're going to use the angle bisector theorem once again. Start by labeling up your triangle as adjacent and opposite. For this angle down below, the opposite side would be z, which would make 10 adjacent, and 10 is right next to that angle, so it works. Meanwhile, on the upper congruent angle, the side opposite is 14, and the side that is next to, adjacent to it, is 5. So we start by labeling up. Now for this, I'm going to use the proportion of adjacent over opposite, giving us 5 over 14 equals 10 over z. Cross multiplying will give us 5z equals 140. And then dividing both sides by 5 will give us z is equal to 28. And that would be our final answer. And that makes sense because to get from 5 to 10, we'd need to multiply by 2. To get from 14 to 28, we'd need to multiply by 2. All right. Thank you guys so much for watching. If you have any questions, please let me know. Other than that, have a great rest of your day.